right, good afternoon, geometries, periods 3 and 4. It's Maze coming at you live from room 308. It's the 14th of May. And what could be more fun than this, because we get to do all kinds of circle stuff. Ain't that awesome? And we might even deal with a triangle or two. All right, today I would like to do a little semester test preview. I'm going to give you some things I know you're going to need. I built the problem. That problem 39 in your textbook that had the 3 circles. Man, I love that. I put that up there yesterday, and I've developed a really awe-inspiring problem for you guys to work with that. Now, to solve that problem, I'm going to give you some things that you're going to have. All right, on page 508, you have the area of a triangle. This is the area of any triangle, but it's particularly useful if you don't have a right triangle. All right, you can find the area of any triangle using one of those 3 formulas. Area is equal to 1/2 BC sine A, area is equal to 1/2 AC sine B, or area is equal to 1/2 AB sine C. The key to this here is 2 sides and the included angle. If you have 2 sides and an included angle, you can find the area of the triangle. All right? Now you're going to find that there's some of the areas of the law of cosines that is also dependent on that, but this will give you the area of the triangle. Okay? Now, the next thing you need is the law of sines. The law of sines is also on somewhere in the neighborhood of page 508. Sine A over the length of A is equal to sine B over B is equal to sine C over C. Now, how does those relationships work? The sine of this angle over the length of this side is equal to the sine of this angle over the length of that side is equal to the sine of that angle over the length of that side. That's the law of sines. Now, the key to use this, the key here is having the measure of an angle and the length of its opposite side and one other angle measure or side length, okay? But the key here is that you need a pair. You need an angle and the side opposite, and then you need one other piece, okay? All right. On page 511, you have something called the law of cosines, okay? Now, one of these 3 versions, and when you find your problem on your semester test, you can pick either one you want. It really doesn't matter. But anyway, it says that a squared is equal to b squared plus c squared minus 2ab cosine a. Notice the pattern. Look at that. B squared is equal to a squared plus c squared minus 2ac cosine b. And of course, c squared is equal to a squared plus b squared minus 2ab cosine c. Okay, that's on page 511 of your text. All right? The key here, if you're given a triangle and you're given 3 sides or 2 sides and an included angle, you need to find the length or the measures of all the angles or the other 2 sides. Okay? Now, if you're finding the measure of the angle, you're going to use your inverse cosine key. You're going to fill in all the numbers, you're going to solve it for the cosine of the angle, and then use your inverse cosine. I highly encourage you to practice that, okay? And then also, equation of a circle. This is 10.7. That's the general form of an equation of a circle with centered h and k, all right? You'll need that, okay? And then finally, we're moving into arc length, and I've got an example on the board for you for that. So the arc length of AB divided by 2 pi r is equal to the measure of arc length AB divided by 360, or if you clean all this up, it looks like that, okay? Now, I decided to put an example up here for you. Makes things a little bit easier. So this is what I got. I've got my whiz-bang circle. It has a radius of 12, and I have an 80-degree angle. I would like to know the length of this arc. Notice I said length. I didn't say measure. I want the length of that arc. To measure that would be 80 degrees, right? It's a central angle. All right, now, the circumference of a circle, 2r times pi, okay? Now, how much of that circumference do I want? I want 80/360ths of that circumference. I only want a portion of it. I don't want the whole thing. No, I only want this much of it. I only want 80 degrees of the entire circle. That's all I want right here, okay? All right. So that's how I would set that up. 80/360 times the radius times 2 times pi. That will give me the length of the arc. Now, if I want the area of the sector, I will find the area of the circle, pi r squared, and I will multiply that times 80/360. And that will give me the area of the sector. You will need to be able to find the area of a sector. I'll say it again. You must know how to find the area of a sector. Okay, so that's a quick little insight into your semester test. It's coming, folks. It's coming faster than I care to admit, but it is coming. So please get your chapter 11 finished up. This little area, the sector and arc length, that's actually the first section in that. Then we're going to move into some volumes and some surface areas of some three-dimensional solids. I plan to cover a few of those tomorrow. All right, so keep the work coming in. You guys doing a great job. Get those CFCs done. Get those chapter tests turned in, and we'll go from there. All right, talk to you guys tomorrow, man. Have a great day. Mays out.